Hi everyone, my name is Celine, this is Timo, and we are here to give you a quick overview of Aptiv's approach to software and hardware. An approach that is flexible, modular, supports safety-critical applications, and is sustainable over time. So in other words, one designed to deliver the full promise of the software-defined vehicle, which is incredible. We have always the latest safety features, always the latest in-cabin entertainment, and the potential of new ways of communicating with our customers. But most importantly, we have a user experience that evolves through the life cycle of the vehicle. We have a vehicle that is new, alive, and responsive to the owner's individual needs. And ultimately, we can say the software-defined vehicle is all about personalization. When we talk about SDV, we have three major important points to talk. We have the software flexibility, the hardware scalability, and the updatability. Timo starts with the flexibility.
Now, the key thing that we have to get away from is this mindset of developing software just for one dedicated compute platform or processor. Because there are several reasons why you would change in hardware or SoC, system on chip. One is supply chain resilience. Maybe you want to implement a multi-source strategy. Or maybe you want to add a new feature that now requires more memory or more compute, etc. Or maybe you just want to have an architecture that scales from entry level to premium. Now, doing this today is difficult for several reasons. First, changing software to a new platform is a lot of effort. Second, software is still developed program by program in many cases, and that causes a lot of fragmentation in the software space and very little ability to reuse software across different vehicle models. Third, just changing small parts of the hardware often requires a major redevelopment or even full redesign of the software. And finally, there is still a lack of standards and APIs. Now, Aptiv's middleware addresses these challenges by fully abstracting the software from the underlying hardware. And that abstraction is very powerful because it sets OEMs free by enabling high degree of software reuse, which eases development and maintenance. I'll give you an example. We recently ported the major part of our ADAS stack to a new real-time operating system in just 1 week. And we ported to a new SoC in less than 2 weeks. Without the middleware in place, this would have easily taken months.
Besides that, here at CES, we are showing two open server platforms, demonstrating comparable UX software features and performance, even though they are built on completely different hardware configurations. The one on the right is based on our typical production configuration, and this is essentially what many people think is the required hardware configuration for the high-end infotainment. Aptiv actually launched a program in China late last year using this one. The one on this side is based on a Samsung V920 running a Wind River Edge middleware, including our VxWorks real-time operating system. So as a result, you can see we have the same software application, the same consumer experience, despite they are running on two different hardware configuration and real-time operating systems.
Now, if you look at this, you realize that your approach to applications can suddenly become much more flexible, because depending on the system requirements, you can run applications on a wide array of devices on this architecture. Here, for instance, we're running compliance ADAS functions on our central vehicle controller, or CVC. However, as we step up to high levels of functionality and autonomy, such as L2+, we need more and more specialized compute resources to support those higher workloads. And this is where the open server platform comes into the picture. This one supports the AI/ML processors and workloads that you need to drive, for instance, a hands-free automated driving stack, which is in this case powered by TI's TDA4 processor. Now, features like this will typically be sold to consumers as vehicle options. So having this architecture in place is a great way to scale across multiple domains, and it was one of the underlying design principles when we created the reference architecture for our Gen 6 ADAS platform.
Another important point to talk about is mixed criticality, because now in automotive, the requirement that stands above all else is safety. As the industry continues to up-integrate features and functions onto a few powerful compute platforms, that has to happen in a way that ensures that all the safety-critical applications continue to operate freely. There are several Aptiv and Wind River technologies that gives you an edge when it comes to bring all the safety-critical applications to the software-defined vehicle. We have three major differentiators. First of all, we have the Wind River's hypervisor Helix. The second one is our support for containerization. And our third Aptiv differentiator is our ANO solution, which guarantees deterministic behavior for all the critical functions. But the flexibility becomes even more critical with the upcoming regulation, such as the EU and ECE Regulation 156, which will require a full management software update system for all the vehicles beginning of July this year.
Now, if you look a bit further ahead, with this software architecture in place, mixed criticality can truly become a reality. What we're demonstrating here today and premiering at CES 2024 is a new solution that combines L2 automated driving, automated parking, as well as integrated cockpit controller functions, all within a single compute platform. OSP Fusion is powered by a high-performance SoC that supports both the containerized environment of Wind River Linux and the VxWorks real-time operating system, running side by side. We think that fusing ADAS and cockpit domain onto a single high-performance compute platform allows OEMs to optimize costs while still enabling feature-rich applications and systems for low levels of autonomy. However, even with the best on-vehicle architecture in place, we still need to have the right edge-to-cloud toolchain to support it. Because regardless of whether your function is rated QM or SLD, it can evolve and improve over time with pre-integrated DevOps tools from Wind River using a digital feedback loop. And this is showing here on the screen, so we can show how we upload select performance statistics from the vehicle directly to the cloud, aggregate it on fleet level, bring it to the developers so that they can tune the software, push it back to the vehicle over the air, and with that complete the digital feedback loop, all behind a single pane of glass.
So with that, thank you for joining us in our tour over Aptiv's approach to software and hardware.